Yes, students, in the previous class, we have discussing the ninth standard chapter Quadrilaterals. I think students in that chapter you have already studied some of the concepts and the properties of the parallelogram, and also we have seen some of the problems. We have seen some of the problems. So today we should continue with that chapter quadrilateral. So in that chapter, very important theorem is there, that is midpoint theorem. Midpoint theorem. So which helps us to simplify the given problems. So it will help us to simplify the problems. So now we shall see the statement. What will be the statement? So it is called as, this theorem is called as midpoint theorem. Its statement is the line segment joining the midpoints of two sides. The line segment joining the midpoints of two sides of a triangle is half of the third side. Is half of this third side and is parallel to the third side. In this theorem, it states that statement is the line segment joining the midpoints of any two sides of a triangle is half of the third side and it is parallel to the third side. So students, here I am not going to prove that theorem. So for the efficiency of the time period, so I will explain how it will be equal to half of the third side and how it is parallel to the third side. Just I will explain it through the diagram figure. Okay. Now students, so for this we will draw a triangle. So here I will take up a triangle. So call this as a triangle ABC. It is a triangle ABC with sides AB, BC and A. So if you mark any 2 points, on the two sides of a triangle, I will mark. So here I will mark a point and also on the point E. I will mark a point on AC. So AC and AB. So mark a point on side AB and AC. So call this as XY. So if you join these 2 points, so we will get a line segment. That is XY. So according to the statement of the theorem, this line XY, it is half of the third side. So here we have to understand the concept of the theorem. So in a triangle, so the line segments joining the midpoints of two sides, any two sides. So consider, I have considered AB and AC as the two sides and BC as the third side. And I have marked the midpoint of this AB. Say it is X, or you can take any alphabet. So and another midpoint on the side AC. another midpoint on the side AC, say this point as Y. So if you join these two points, if you join those two points, you will get a line segment. So this line segment will be, according to this statement, so this line segment will be half of the third side. So it is half of the third side, and also this is parallel to the third side. It is parallel to the third side. So that means XY is parallel to BC. XY is parallel to BC and XY is half of BC. So now we will write that. So in triangle, so ABC, in triangle ABC, so X and Y are the midpoints, the midpoints of AB and AC, AB and AC respectively. So now, according to the statement, by the statement of the theorem, the statement of the theorem. Now we will write, so XY is half of BC. XY is this, the length of XY is half of BC. And also, or in other words, we can write this, or we can write this, BC is twice of XY, 2 into XY. So XY is half of BC, or BC is 2 times of XY. So both are same. So XY ಅನ್ನುವಂಥದ್ದು BC ಗಿಂತ ಅರ್ಧ ಇದೆ ಅಂತ ಹೇಳ್ಬೋದು, ಅಥವಾ BC ಅನ್ನುವಂಥದ್ದು XY ನ ಎರಡರಷ್ಟಿದೆ, ಇಸ್ 2 times of the XY. ಸೊ ಈ ರೀತಿಯಾಗಿ ಎರಡನ್ನೂ ನಾವು ಯೂಸ್ ಮಾಡ್ಬೋದು ಫಾರ್ ದಿ simplification of the problem. And another one is, so this line segment XY is parallel to BC. So XY is parallel to BC. So this this is enough to you to simplify the problems on this theorem. Okay, students. So we will see the next. We will see the problems on this theorem by using this midpoint theorem. Okay. Now students, we will take up the problem on exercise 7.2. So, the problem is ABCD is a quadrilateral. ABCD is a, in the figure ABCD is a quadrilateral in which PQRS are the midpoints of the sides AB, BC and CD, and DA. AC is a diagonal. AC is a diagonal. So then we have to show that SR, the side SR is parallel to AC and SR is half of AC. So and second one is the side PQ is equal to side SR, and this third one is PQRS is a parallelogram. So these are the things we are going to do here. So try to understand the problem. Given figure ABCD, the given figure ABCD, so PQRS, so these points are the P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, and S is the midpoint of AD or DA. And AC is the diagonal. AC is the diagonal. Then we have to show that this this line segment is parallel to AC. This line SR line segment is parallel to AC, and this is off of this AC. And second one is the length of PQ. Length of PQ is equal to length of SR. So these two sides are equal. And then lastly, we have to prove that PQRS is a parallelogram. Now students, we will move on step by step. So first one, so before going to simplify this problem, so here, so observe this figure. So if you consider only the plane figure which I am taking, consider this plane figure, consider this plane figure. So what do you call this plane figure? This one ABC. Yes, it is a triangle. So now we will write in triangle ABC or ACD. In triangle ADC. In triangle ADC. So now S is the midpoint of midpoint of AD, and R is the midpoint of midpoint of the side DC or CD. DC. So S is the midpoint of AD, R is the midpoint of DC. Now we can write. So therefore we can write SR is equal to SR is equal to half of AC. SR is equal to half of the third side. So this is the AC will be the third side of the triangle ADC. Half of SR is equal to half of AC. Call this as an equation number 1. And also we can write SR is parallel to AC. Yes, SR is parallel to AC. SR is parallel to AC. Call this as an equation number 2. On what basis we are going to write this? So, on the midpoint theorem. The reason is the statement of the midpoint theorem. By midpoint theorem, we have to do this. Now, similarly, students, so if you consider the triangle ABC, so next part is if you consider triangle ABC, consider triangle ABC. In triangle ABC. Now, as we applied the triangle ADC, P is the midpoint of AB, ABC, P is the midpoint of P is the midpoint of AB and Q is the midpoint of BC. Therefore, if you apply the midpoint theorem for this triangle, therefore we can write PQ. We can write PQ is equal to half of AC. PQ is equal to half of AC. Half of AC, because here AC is also a third side of the triangle ABC. Call this as an equation number 3. And also this PQ is parallel to AC. PQ is parallel to AC. Call this as an equation number 4. Now students, so we have written this by using the midpoint theorem. Midpoint, sorry, here it is midpoint theorem. The reason is midpoint theorem. So here also it is midpoint theorem. Midpoint theorem. So now observe here, we have to prove SR is parallel to AC and SR is equal to half of AC. So this we have written. So that means we have already proved. So and second one is we have to prove PQ is equal to SR. So from 1 and 2. So here we have got the answer of the first one. SR is parallel to AC and SR is half of AC. This is already we have proved here. So second one we have to show PQ is equal to SR. PQ is equal to SR. So for that, so here from 1 and 3, from equation number 1 and 3. Now we will write from 1 and 3. So if you observe the equations 1 and 3, so here and here. So what will be the RHS? So this RHS is here also half of AC. So here also half of AC. RHS are same, equal. So if the RHS are equal, then we can write. So LHS are also equal. By axiom 1, if equal things are so equal to one another, they are equal. So therefore from 1 and 2 we can write PQ is equal to SR. PQ is equal to SR. What we needed to prove here. Second one, we got the second answer. PQ is equal to SR. So and the third one is PQ RS is a parallel. So observe here we have proved PQ is parallel to PQ is equal to SR. So that means opposite sides are equal. So to show that it is a parallelogram, here the opposite sides are equal. So then we have to show. So these opposite sides are also parallel. They are also parallel. For this, so observe from 2 and 4. From 2 and 4 Equation number 2 and 4. So observe here, SR is parallel to AC. Similarly, this PQ is also parallel to AC. So this in the figure, observe here, the side SR is parallel to AC. Similarly, PQ is also parallel to AC. That means PQ is parallel to SR or SR is parallel to PQ. So PQ is parallel to SR. PQ is parallel to SR. So therefore, PQ is parallel to SR, and this opposite side PQ is equal to SR. It is already proved. So this PQ is parallel to SR, and also PQ is equal to SR. These are the opposite sides. These are the opposite sides. Similarly, we can write. So this QR is also equal to PS, and this PR is also parallel to each other. So therefore, we can say that EQRS is a parallelogram. So therefore, PQRS is a parallelogram. PQRS is a parallelogram. Students, I think you have understand how to do this. Okay? So observe clearly and try to understand the concept here. ಚೆನ್ನಾಗಿ ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ಅಷ್ಟೇ ಇದೇನಿಲ್ಲ ಸರಳವಾಗಿದೆ ಕಷ್ಟ ಏನಿಲ್ಲ. So we will move on to the next problem. Now students, observe the problem here. Observe this problem. So here it is given that ABC is a triangle, right angle at C. So a line through the midpoint M of hypotenuse AB and parallel to BC intersect AC at D. Show that first one D is the midpoint of AC, second one MD is perpendicular to AC, third one the side CM is equal to MA is equal to half of AB. Okay, students. So in this we have to draw the triangle, that is right angle triangle. So here I have drawn the right angle triangle. ABC is a right angle triangle. So it is they have given it is right angle at angle C. So then a line through the midpoint of midpoint M of the hypotenuse. So if C is the right angle, then the side which is opposite to the right angle is hypotenuse. So here AC is the hypotenuse and M is the midpoint of this hypotenuse. So if you draw the line segment L, so this line segment it is parallel to BC. This line segment is parallel to BC, intersect AC at D. So this will intersect. So the line segment AC at D. So then we have to show that. So we have to prove D. This D is the midpoint of AC, and this MD is perpendicular to AC. So then CM is equal to AM. So this length is half of the AB. So for these students, first one, in triangle ABC. So M is the midpoint of AB. Know that M is the midpoint of AC. And also they have given that MD, this MD is parallel to BC. MD is parallel to BC. So by the corners of the by the count of the midpoint theorem, we can write AD is equal to DC. You can write AD is equal to DC. So from these data, this MD is parallel to BC and AD is equal to DC. We can say that. So this only happens. This happens only when D is the midpoint of EC. D is the midpoint of EC. This is the proof of the first one. Second one, we know that this line segment L is parallel to BC. So these two are parallel lines. And so since this is a midpoint and this is a parallel line, so we have to write, we can write angle 1 is equal to angle C. Angle 1 is equal to angle C. So the value of angle C is 90 degree. So therefore, and the value of angle 1 is also equal to 90 degree. So since these two lines are parallel, so angle 1 is equal to angle C. So and the value of angle C is 90 degree. Therefore, the value of angle 1 is also 90 degree. So this happens. So if this angle is equal to 90 degree, then we can write that. So this line segment is always perpendicular. So if a line segment is perpendicular, then only that angle, this angle will be 90 degree. So this is the proof of the second one. And for the third proof, we have to consider two triangles. That one AMD, another one CMD. These two triangles. Consider these two triangles. So in these two triangles, side AD is equal to side CD. Side AD is equal to side CD. So this is already now. So we have written and proved. So and angle 1 is equal to angle 2 because these two are 90 degree because the line segment L. So this MD is perpendicular to AC. So therefore these two angles will be equal to 90 degree. And also we know that MD is a common base. MD is common for the triangle AMD, and also this side MD is common for the triangle CMD. So therefore, by applying SAS axiom, so these two triangles are congruent. So by SAS axiom. So therefore, we can write AM is equal to CM. So this AM is equal to CM because these two are the congruent triangles and these two are the corresponding chords of the congruent triangles or corresponding sides of the congruent triangles. Therefore, AM is equal to CM. All this as the equation number 1. So given that M is a midpoint of AB, so M is the midpoint of AB. So therefore, we can write this AM. So AM it is always half of this line segment AB. AM is always half of AB. So therefore, we can write AM is equal to half of AB. So if you observe from 1 and 2, so AM is equal to CM and the same AM is equal to half of AB. So we can write that CM is also equal to half of AB. So this since AM is equal to CM, we can write not only AM is half of AB, CM is also half of AB. So this is the proof of this problem. Okay, students. So observe clearly and try to understand. Okay, I think you have understand this concept how to simplify the problems. So there are also many problems are there in exercise 7.2 also. So you have to try to simplify those problems by using the video lessons of given in the chapter quadrilateral. So what are the ideas I have given to simplify the problems. So try to uh, simplify the exercise 7.2. So this completes your chapter quadrilateral. We will see in the next lesson, the next class. Okay.